prove by induction that 1 plus 8 plus 27 plus n power 3 is equal to what we have on the other side. So how can we prove this by induction? Okay, so to start with, to prove this by induction, it's important to note that induction is done in 3 steps. I hope we all know that by now. So since induction is done in 3 steps, let's bring out the 3 steps that are supposed to prove this. So step 1. So step 1, I'll just demarcate here, also known as the base case. Step 1, the base case. For step 1, we have to prove that it is true. So we need to prove that it is true for the simplest integer we can use is 1. So I need to prove that it is true for n is equal to 1. So to do that, what we're getting is this part that we have here from our statement. We get this part, which is n power 3. Then this part as well. So this is equals to 1 over 4 n squared n plus 1 squared. So we're going to replace n with 1. Let's see what we get. This will give us 1 power 3 plus 1 over 4. Sorry, it's equals to 1 over 4. 1 plus 1 in there, we'll just get it 2 squared. So this will give us 1 is equals to 1 over 4. 2 squared is simply 4. So the 4 and the 4 will cancel, meaning that 1 is equals to 1. What does this mean? This is true. This is true for n is equals to 1. So we're done with step 1. So basically the base step is just proving that it's true for n is equals to 1, like we've done here. Now let's move on. So I just want to create space. Let's bring in step 2. Step 2 is the inductive assumption. So step 2, I'll put it here. So the inductive assumption. For this one, it's just an assumption that we're making. There's nothing to prove. So for the inductive assumption, we can say we assume that it is true. It is true for n is equals to k. That's our assumption. So since it's just an assumption, then we can say that where there's n, just replace it with the k. So what do we get? We get 1 plus 8 plus 27 plus, where there's n, we put a k power 3. This is equals to 1 over 4 k squared, open bracket, k plus 1 squared. It's just an assumption, meaning that just replace n with k. You assume that it's true, then you leave it there. Okay. So now that we're done making the assumption, let's move on to step 3. So step 3. For step 3, we prove for n is equals to k plus 1. Okay. So how do we do this? From the statement, this is what will happen. From the statement, the original statement, you can say we have 1 plus 8 plus 27 plus 3 dots plus. Now, this is where most people make a mistake. This is what you do for this part. Where there's n, don't replace it with k plus 1 first. What you do is, where there's n, replace it with k. Now, also it's supposed to be power 3. What comes after k? It's k plus 1. So now after this, you say again plus, where there's n again, replace it with k plus 1 raised to the power 3. So you have two things, k power 3 and k plus 1 power 3. Okay. So this whole thing is equals to, on this side, just replace n with k plus 1. So 1 over 4, k plus 1 squared, open bracket, k plus 1 squared, like that. Now, the whole reason why we did that is because we want to use the assumption. Remember, the assumption is 1, 8, 27, k power 3. which is this part that we have here, 1, 8, 27, k power 3. So this part here, just underline it. Okay, not working. What is this? This part here is the assumption all the way up to k power 3. So we're going to replace this whole part which is underlined with this part because that's the assumption. So we can say that will give us, let's do the replacing. We'll have 1 over 4 k squared, then open bracket k plus 1 squared plus this guy here, which is k plus 1 power 3, which is equals to 1 over 4 k plus 1 brackets squared, open bracket k plus 2 squared. Okay. So now all we need to do is we have to prove that the left-hand side is the same as the right-hand side. Then we can conclude that it is true by induction. So to do that, for these two parts, let's factor out what is common, which is k plus 1 squared. So k plus 1 squared is common. So what remains if you factor out k plus 1 squared? What remains here will simply be 1 over 4 k squared. What remains here will simply be k plus 1, like that. This is equals to, for this side, let's also put this k plus 1 in a bracket like we did on this side. So what we say, k plus 1 squared. So what is inside the bracket there is simply 1 over 4 multiplied by this, which is k plus 2 squared, like that. So k plus 1 squared, let's just write this as it is, 1 over 4 k squared plus k plus 1. This is equals to k plus 1 squared. So what do we have in the bracket? So if we expand what we have here, we're going to get 1 over 4, open bracket, k squared plus, if this multiplies by itself, we'll get 2k, not 2k, but 4k rather. So 4k, then plus 4, like that. So k plus 1 squared, 1 over 4, k squared plus k plus 1. This is equals to k plus 1 squared. What do we get there? So 1 over 4 times k, we simply get 1 over 4 k squared. 1 over 4 times 4k is just k. 1 over 4 times 4 is just 1. Now, we can see that the left-hand side is equal to the right-hand side. Then we can give a conclusion. We can say, since it is true, for n is equal to k plus 1, then the statement which is where we're coming from, the statement is true by mathematical induction. There we have it. We've proven by induction that this is true in 3 steps. I hope it makes sense. Determine the value of a and b if 1 plus root 2 raised to the power 5 is equals to this expression that we have here. Okay, so this is under binomial expansion. So to find the values of a and b, we will need to expand what we have on the left-hand side. So focusing on the left-hand side first, let's see how we can expand. So expanding this, this expression, we have to know how everything works. So first of all, we need to know that we have to expand using the formula, the summation. Just for example, if you have a plus b raised to the power n, it's given by starting from n is equal to 0 all the way up to n. So it's given by n combine r, or it's r that always starts from 0, a n minus r b to the power r. So In this case, our A and B are just representing this part and this part. I'm just using this as a general form of the binomial expansion. So A is representing the first term, which is 1. B is representing the second term, which is root 2. So I hope we'll get where it's going. But what we're looking for are actually the coefficients. So without even using that, let's go ahead and see what I'm talking about. So the combination, the first combination, since we're starting from 0, we can say it's just an expansion. So n combine 0. The first term is 1 raised to the power n minus 1. That's what we're saying. So in this case, our n is 5. So we're supposed to use 5 instead. You can just redo it. So we can say 5 combine 0. First term, 1. 5 minus 0. Minus 0. So 5 minus 0. Then the second term in this case is root 2. So the root of 2, brackets raised to the power 0. Well done. Remember, it's a summation. Second part is 5 combine 1. First term, 1. So 5 minus 1. Second term, root 2. So root 2 raised to the power 1. This one here. Next term is 5 combine 2. 1 to the power 5 minus 2. That's the first term, 1. Second term is root 2 raised to the power 2. Next term is 5 combine 3. So what we get? 1, the first term, 5 minus 3. Second term is root 2 raised to the power 3. Like that. The next part is 5 combine 4. Remember, we have to go as far as n, which is 5. So 1 raised to the power 5 minus 4. Then from there we can say root 2 raised to the power 4. Like that. Let's bring out the last term here, which is 5 combine 5. 1 raised to the power 5 minus 5, the first term. Second term is root 2 raised to the power 5. Okay. So now that we have this, let's see how this simplifies. So this implies that 5 combined 0 is 1. 1 to the power 5 is 1. This to the power 0 is 1. So everything here is just 1. Plus, what do we have here? 5 combined 1 is 5. 1 to the power that is just 1. This is the root of 2. We are here now. So 5 combined 2, that is 10. This is just a 1, we won't even write it. Root 2 squared is simply 2. 5 combined 3, 10. This is just 1. Here, what do we get? We can write this expression as root 2 squared times root 2. So that the powers can add, yes, we have a power 3. We want to cancel out the square root and the square. We'll come back to it. This part, what we have? 5 combined 4 is 5. This is just a 1. We have root 2 to the power 4. So root 2 to the power 4 can be written as root 2 squared, again squared, because 2 times 2 will give us a 4. Plus, the last part is 5 combine. 5 combine 5 combination 5. So 5 combination 5, which is just, sorry, why am I writing this? 5 combination 5 is just 1. Then this is just 1. Root 2 to the power 5. So root 2 to the power 5 can be written as root 2 to the power 4, whatever result we'll get here, times root 2. Let's simplify. This implies that we have 1 here. Here we have 5 root 2. Here we have 20. This will give us root 2 squared is 2 times 10, that is 20, root 2. 5, root 2 squared is 2. This is a 2, so 2 squared is 4. So 4 times 5, that's another 20. So since root 2 raised to the power 4 is as good as 4, this means that this is a 4. 4 times this will simply give us 4 root 2. Okay, let's group like terms. The like terms in this case, we have 1, 20, 20, which will give us 41 plus 5, 24. What we get? 29. 29 root 2. Okay, so now that we have this, we can clearly see that what we have there is the same as this. So A is 41. Our A is 41. What we have here is this. So our B is 29. There we have it. I hope it makes sense. So a 3 by 3 determinant is given by this 3 by 3 matrix. The question is, show that the determinant can be reduced to this and clearly stating the values of A, B, C. So for this 3 by 3 matrix, all we need to do is we need to find the determinant. Now, to find the determinant, there are a few things that you need to know. The first thing is that finding the determinant, we have to state, first of all, we can say from the first row, this is a plus, this is a minus, this is a plus. Or if you want, you can use a diagonal method. Either way, you still get the same result. So this is what will happen. Let me just mark it here. So the determinant will be given by, we first get what we have in the first row, which is this part. So if we're getting n, open bracket, n minus 1, then we're going to hide its row and column and multiply by that 2 by 2 matrix. And that 2 by 2 matrix will be representing the determinant of the 2 by 2 as well. This is what I mean. We're going to get n plus 1, like that. Then we hide everything as in the row and the column. So the 2 by 2 matrix that will be formed is 1, negative, n plus 1. So for this one, I'll just factor out the negative. Then we have n and 1. So that's a 2 by 2 matrix formed. Please take note that this is the same as this. We just factor out the negative. The next part will be a minus, because we have a minus there. So minus n plus 1. The n plus 1 is this one that we have here. Then now again, we're going to hide its column as well as its row. Of course, that's how we find the determinant of a 3 by 3. So we'll get 0, 1, the remaining 2 by 2 matrix, and 1, like that. The last one is negative 1. The 2 by 2 formed will be everything except this column and this row. So we get 0, 1, 1, negative, n plus 1. Like that. Okay. So now this means that our determinant will be equals to n plus 1. So 1 times 1, remember it's major diagonal minus minor diagonal. So 1 times 1 is 1. This times this, since they'll be subtracting, then we'll have a positive. This will change to a positive, hence we'll have n plus 1, like that. So this times this 1, then this times this will have this, but since they are subtracting, this negative will become a positive. Minus n plus 1, in brackets, this will give us a 0, minus this will give us n. Minus 1, open bracket, this will give us a 0, minus 1, like that. Then from there now, we can say the determinant is equals to, so let's see what we have now. If you look at these two, this one and this one, let's see how we can simplify the two. So to start with, we can first start by saying, let's expand this part. This should multiply with this, then this should multiply with this. Then there, we'll see what happens there as well. So this is what will happen. We have this multiplied by this 1 here, we'll get n n plus 1, like that. Then if this multiplies this, they are the same. So it will just produce n squared, n plus 1 squared, like that. This negative n and this negative will just make a positive. So we'll have n plus 1. Whatever we have here will just result to a positive 1. Okay. Now from there, we can see that this and this are like terms. This one here and this one here are like terms. But we want to see how we can separate the two. So to do that, let's rearrange and write them as follows. So the determinant will be equals to, so let's start with this part, which is n, open bracket, n plus 1 in brackets squared. Then we have these two. They're like terms, but don't put them together. Let's just leave them separate. We have n plus 1 plus n plus 1 plus 1. This is what we have. Okay. Let's see how it proceeds from here. So if you look at this part, we can factor out what is common. What is common is n, open bracket, n plus 1. Look at this part, we can factor out what is common. What is common here is 1. So for the first part, we can say, let me even bring it here. I have enough space here. What is common here is simply n plus 1. So if we factor out what is common for these two parts, what remains here is the same n plus 1. I hope you get it. So for these two, we factor out this. What remains here is this one. What remains here is 1. We close the bracket. For these two, we said what is common is 1. So let's factor out 1. So if we factor out 1, what remains here is simply n plus 1 plus 1, like this. Now, if you look at this, this bracket and this bracket are the same. So let's factor out the same bracket, which is the same. What do we get? What we're going to get in this case will be n plus 1 plus 1. So this is the bracket which is common. So if we factor it out, we factor out this, what remains here is this guy, which is n plus 1. We factor out the bracket here, what remains is 1. So we'll say plus 1. Now, if we look at these two brackets, they are exactly the same. So we can just introduce a square now, meaning that the determinant is equals to, open bracket, n plus 1 plus 1 squared. Now, if you go back to our question, remember it says that, show that the determinant can be written in this form, clearly stating ABC. So I hope you're able to see now that the form we're talking about is, I'll just write it here, the form is an squared plus, let's do this, so an squared plus bn plus c squared. Now, we can see that we don't have that part yet. So what we can do instead to have this format, we can say this expression that we have here, so just what we have inside the bracket can be expanded. So n times n will get n squared. N times 1 will get n. And lastly, we have plus 1 squared. So in this case, after we do our expansions, we can clearly see now that the coefficient of n squared is a here. meaning that the coefficient of a squared here is 1. So a is equals to 1. Coefficient of b, likewise. Then the constant 1 is the same constant as c. So c is 1. So there we have it. Now, let's answer this question, which says, show further that the determinant can be written as this form. It's the same determinant that we're talking about. Now, how can we write it in this new form? To do that, we need to pick it up from somewhere. From everything that we've done, we need to pick it up from somewhere. And the best place to pick it up from is here. Let me just do this. We can pick it up from here. Why here? Because it's this part where we already have n squared, n minus 1 squared, which is this one here. So let's pick it up from this part, then we see how we can simplify it to that. So we're going to say, this is part 2. We know that since the determinant can be written as, so I'll start with this, which is n squared, open bracket, n plus 1 squared. Then we have these two expressions for n minus 1 multiplied by n. So what I can do now is I can group like terms. I'll get this and this, I'll put them together. What I'll get will be 2n plus 1, and lastly plus 1. So I just put these two together because they're like terms. That's what we have. So I've picked it up from here, not from the beginning. Okay. So now that we have this, how can we proceed from here? So it's important to note that the first thing we can do is we can expand. So we can say n, or rather the determinant is given by n squared, n plus 1, brackets. We expand here, hence we obtain 2n squared, plus we expand here, we obtain 2n plus 1. This 2n squared, let's separate it. So we have n squared, n plus 1 squared, plus, separating this, we're going to get n squared plus n squared. Remember, n squared plus n squared is the same as 2n squared. Then we have plus 2n plus 1, like that. So the next thing we'll need to do is we need to separate the 2n as well. I wish we did it in the same step, but it's fine. So the determinant is equals to n plus 1 plus n squared plus n plus 1. That's what we have. So if that's the case, why do we need all this? So the determinant, you'll see how it will pan out in a minute. So n plus 1, like that. There's a squared here. So we'll get 1n squared and leave it as it is. Now for this part, for these two, factor out what is common, which is n. So what remains? N plus 1. For these two, factor out what is common, which is 1. What remains? N plus 1, like that. Move on. So the determinant is equals to n squared, n plus 1 squared, plus n squared. So what is common here is n plus 1 for these two parts. Then you can see that n plus 1 is common. So if you factor out n plus 1, what remains here is n. What remains here is 1. Then from there now, we can say the determinant is given by n squared, n plus 1 squared, plus n squared. These two are the same. So that's the same as n plus 1 in brackets squared, as shown. Because remember, we're trying to show that this is equals to, I hope you can see both here. We're trying to show that this is equal to this expression, which is what we have there. Okay, so that was part 2. Now, part 3 of the question, Part 3 of the question says, express this number as the sum of the three squares. So the sum of the three squares we're talking about, these are the three squares. This is part 3. So let me just do it like this. So the sum of the three squares we're talking about is the same expression, but we want to write it as n plus 1. Then we have squared plus n squared plus n plus 1 in brackets squared. So we have a square, and a square. So what we're saying is this is the sum of three squares. So how can we express that number as a sum of three squares? This is what I want to do. We need to find the value of n. So we're going to equate this whole thing to that number, then find the value of n. But the good part is that everything that we've done so far is equals to the determinant. So we can pick up where the determinant is in its simplest form. And in the simplest form is this one that we have here. Sorry, this one here. So we can say, I want us to understand it. So we can say, let me just put it here. The determinant is given by, remember the simplest form? The simplest form is n squared plus n plus 1 squared. Then remember, we have to put this number as a sum in the simplest form, meaning that this value that we have here, then we can say that, okay, to find the value of n, we can say n squared plus n plus 1 squared is equals to the same number that we have, which is 24,649. Okay, so let's find the value of n. So to find the value of n, in this case, we can say that, let's just introduce a root to both sides to get rid of the square. So we have n squared plus n plus 1, which is equals to, if we introduce a square root to both sides, the square root of this big number that we have here is simply 157. We can push it to the other side, so that n squared plus n plus 1 minus 157 is equals to 0. So n squared plus n minus 156 is equals to 0. So now we have a quadratic equation. So let's quickly solve the quadratic equation. So to solve this quadratic equation, let's just use the formula and say n will be given by negative b plus or minus the square root of b squared minus 4ac. Everything is divided by 2a. So n is equals to, in this case, our b is 1. So we have 1 squared minus 4. What is our a? 1. What is our c? Negative 156. Like that. Everything is over 2a, so it's just over 2. So n is equals to negative 1 plus or minus. Everything inside the bracket there will just give us square root of 625 over 2, which is negative 1 plus or minus 25 over 2. So if we compute what we have there, the value of n will be 12, and the other value of n is negative 13. Now, there's no need of getting both, we can just get one of them. So now that we know the value of n, how can we express that number, remember that big number, as a sum of three squares? A square number is simply a number that can be multiplied by itself to give a certain number. So, for example, 4 times 4 is 16, meaning that 16 is a square number. 4 itself is a square number because that is 2 times 2, just like that. So, this determinant can now be written as, so let's replace. Let's start with 12. If we put a 12 here, we'll have 12. If we put a 12 here, we'll have 13. Remember, there's 2 in brackets. Plus, this is just 12 squared. This is 13 squared. So, this will be equals to We have 13 times 12. What do we get? What is 13 times 12? We have 156. So this is 156 squared plus 1, or let's just leave it as 12 squared for now, plus 13 squared. So already we're done. This whole value that we have here is equals to 24649. You can prove that. So we have expressed it as sum of three squares. This is a square, this is a square, this is a square. But we can further do it in this way. We can further say 156 squared will give us 24,000. So this is 24,336 plus this is 144 plus this is 169. Okay, so this is equals to 24,649. Now understand that even if you use 13, you still get the same result. So now these values that we have here, if you add these three, remember they are squares. So if you add these three square numbers, what you get is this value that was being requested for. Hence, we have answered this question. Express as the sum of three square numbers. So these are your three square numbers. I hope that's okay.